Hello everyone, my name is Neha Kardam and this is the first lecture on Introduction to Microprocessors. In this lecture, we're going to learn about the basics of microprocessors, microcontrollers, and central processing units, etc. So let's get started. So I want to start this lecture by asking you this question, which is how many computers have you used today? So take a pause and think about it. Or maybe make a list and then see like how many computers you have actually used. Okay, so I'm going to move on to the next slide and we'll show you uh, the number of computers I use today. So let's see. So today I used Alexa device. I used microwave for my coffee in the morning. I used Apple Watch to see how many steps I have walked today. I used my car, which has the automatic systems. Um, so I use that, and then I use the CarPlay, which is in the car. So which has also a small computer. And then I use the traffic lights. And they do also have small computer in them. And then I use the desktop. So you might be thinking at this point, like, how could like a traffic light or maybe a CarPlay have like a big computer? So here we are not talking about like a huge screen and then there's a CPU. Here we are talking about the microprocessor, which is basically the heart of the computers. So all the computers you see, they have this microprocessor, which is really small. And their close cousin is the microcontroller. Now, what is the difference between microprocessors and microcontrollers? So this question I'm going to answer in the next coming slides, but after this I'll first discuss the CPU, which is called the Central Processing Unit. So you see this CPU, you might have heard the name of CPU before. And this is the block diagram you see of a CPU. And inside the CPU, you have arithmetic logic unit, you have control unit, you have memory unit, and you can see how these arrows are, going in this direction, and then from memory unit, it is going in the up direction. So which means like they are basically, each of these units you see, they can basically communicate with each other. And then on the side, you see you have input unit and the output unit. So let's talk about the input unit. So this input unit, they are needed to enter the program to be executed and data to be processed into the computer. And there are wide variety of input devices which are used. Some of them have been mentioned here. For example, keyboard, mouse, scanners, barcode readers, sensors, and so on. And then on the other side, you see here is the output unit. So this output unit is the end, or you can say here the result is basically displayed or printed on a paper so that user can basically see them. So there are many media and devices that can be used to present the information. For example, you have a monitor which display your information, and printer is your output device, and your CRT displays, flat panel displays, 7-segment displays, or light emitting diodes, etc. You are going to see the application of that in your lab experiments, like which is you will get to know like what different outputs, what different basically elements in your projects are behaving as a output device. Now we have this memory unit. So this memory unit, it can store instructions, data, and results. And this unit supplies information to other units. You can see all these arrows indicates that. So it supplies information to other units of the computer whenever it is needed, and it is also known as internal storage unit, or the main memory of the, or the primary memory, and there is another name for that, which is a random access memory. And then next you have a control unit. So this control unit controls the operation of all parts of the computer, but does not carry out any actual data processing operations. So its main function is that it manages and coordinates all the units of the computer. It communicates with input output device, you can see that, and it does not process or store data because that's the function of the memory unit, and it is responsible for controlling the transfer of data and instructions among other units. So same like a memory unit, because it's doing the same, but here this is the main unit where which is responsible for directly communicating with the arithmetic and logic unit and memory unit. So now coming to the arithmetic logic unit, which is also called ALU. So this unit basically consists of two subsections, which is you can see already here, arithmetic, and the other one is the logic section. So the arithmetic section, its function is to perform arithmetic operations like subtraction, addition, multiplication, and division. So all complex operations are done by making repetitive use of the above operations. And the logic section of ALU basically used to perform logic operations such as comparing, selecting, or matching or merging different datas. So this is about central processing unit. Now let's see next. So next we have microprocessor versus microcontroller. So what is the difference between a microprocessor and a microcontroller? So the picture you see here, it shows both of them. So this is your microprocessor and this is your microcontroller. So the difference between these two cannot be simply distinguished by just looking at them. The both ICs, they are available in numerous type of packages, starting from 6 pins to a large number of pins, and that depends upon its features. And you know, number of people, there are times like they are not very much aware of the difference between the microprocessor and the microcontroller, and mostly they end up considering both of these as the same thing. So in this lecture we are going to explore what is the difference between the microprocessor and the microcontroller. So let's first start with microprocessor and then microcontroller, and then we will basically conclude what is exactly the difference between these two. Okay, so microprocessor, it is a device that moves piece of information between places in electronic memory and performs mathematical operation on data as dictated by software. It's the brain of a computer. So you see, microprocessor is the key component in a computer. It is the main unit on which computer works. In other words, we can say that a microprocessor is a processor packaged in a single integrated circuit. And a microcomputer is a computer that uses a microprocessor as its CPU, which is your central processing unit. Now let's see the block diagram of a microprocessor. You see here, it is the block diagram where this is your microprocessor unit, and the short form is MPU. And you can see how it is connected to the system bus, and this system bus is further connected to different blocks, and these blocks are input port with switches, output port with LEDs, ROM which is the memory, and then read and write memory you have. So this is the memory section. So this microprocessor, they have been used widely in many applications and since they were invented. And if you go back to the history and check, the first commercial microprocessor which was made was of 4-bit and 4004, developed by the Intel and was made available in 1971. And since then, it took a phenomenal success in its development and its applications. So, but there are some limitations with the microprocessor, and these limitations are it requires the external memory chip, which you can see already here. And this memory chip is needed to hold the programs and data because the early microprocessor did not have on-chip memory. And it has glue logic such as address decoders and buffer chips which are required to interface with the memory chip. And then it has peripheral chips which are needed to interface with these input-output devices. So we learned that these microprocessor, they basically relies on external devices for storage and input-output pre-processing to become the heart of the computer. Now let's see next. So now we are going to learn about the microcontroller. Microcontroller, it has a memory and input-output functionality built into the device, or you can say a complete computer on a chip. These microcontrollers, they are often considered as a byproduct in the development of a microprocessor. The fabrication process and programming technique which are responsible in the development of microprocessors has also lead to the development of these microcontrollers. These microcontrollers, they can be found in different electronic devices like televisions, in video games, video cassette recorders, telephones, elevators, etc. These all devices, they comprise of the microcontroller. And now let's move on to the next slide, and this is the schematic internal architecture of a microcontroller. So now here you can see, in addition to those components which were used in the microprocessors, in microcontroller, it has some other peripheral components which are used, as you can see here. So you see here, it has a memory, it has timers, including event counting, event capture, output compare, real-time interrupts it has a watchdog timer, and it can do pulse width modulation. It can convert analog to digital and digital to analog. It has parallel input-output interface, and it can communicate asynchronously and synchronously serial data. And there are many other devices which can be connected to the microcontroller. So all in all, it is like a small computer which and it is different than the microprocessor in such a way that it has its own memory, and all these things you see here, this whole makes up your microcontroller, whereas in a microprocessor it did not have the memory and all those these were basically externally connected to the main microprocessor unit. Now let's conclude the differences between microprocessor and microcontroller. So the microprocessor which you see here, this is your microprocessor. It is an IC which has only the CPU inside it. That is only the processing power which is used, and the example of that is already written here, which is Core i7, and there are many other which can be used, for example Core 2 Duo, i3, i5, etc. So these microprocessors, they don't have random access memory or read-only memory and other peripheral on the chips. So a system designer, if you want to use the microprocessor, then you have to add the microprocessor to the external devices to make it functional. And application of a microprocessor includes like desktop, PCs, laptops, notepads, etc. While on the other hand, your microcontroller, it has a CPU inside it, in addition with a fixed amount of memory and other peripheral embedded, all embedded on a single chip. And sometimes it is also said as a mini computer or a computer on a single chip. And different manufacturers, they produce different microcontrollers with a wide range of features available in different versions. Some manufacturers, for example, Atmel, Microchip, TI, Freescale, Philips, Motorola, etc. These are some of the names of the manufacturers. And in our class, we will be using a microcontroller from Microchip manufacturer, and we'll be doing the programming on that using the MP Lab. So by this point, I hope you understand the difference between the microprocessor and the microcontroller. And here is the end of the lecture, and thank you so much for watching.